Okay, thank you, students. Okay, so I think yesterday we start the third unit. Okay, I hope you all have remember the formulas. Sorry, it went away. Yeah, yeah, Dharmaraj. I will share. Actually, the problem is share the link. I think that is possible, but sharing the entire class is possible or not, I don't know. I will check it. If possible, I will share it. Okay. Yeah, after completing this class, whatever I thought till today, I will share it. Okay, Mogit. Okay. I think we will go with the problem. But anyway, we can't able to complete the third unit. So it will take another more week to complete. So you people have known the formulas. And yesterday we solved two problems. Take down the third problem. Take down the third problem. A current of 2 ampere passes through a coil of 350 turns wound on an iron ring of mean diameter 12 centimeter. The flux density established in the ring is 1.4 Weber per meter square. Find the value of the relative permeability of iron. So I told you already, whenever you given the statement, try to draw the diagram. Okay, it's a iron ring. I think we'll consider as a ring, and a coil is wound around the ring. Okay, and a 2 ampere current is flows through that, and the number of turns in the coil is 350 turns, and the mean diameter of the ring is 12 centimeter. The diameter of the ring is given 12 centimeter. Okay, and the flux density is also given 1.4 Weber per meter square. We are supposed to find out relative permeability of iron. Relative permeability means what? We are supposed to find out nu R. Okay, and we all know the formula which is used to find out B is given, but for H we all know Ni by L formula. N is given, I is given, and we are supposed to calculate the L. So I think the suitable formula to calculate the nu R is B equal to nu H. People kindly take down the value. Okay, and we all know the diameter is given, so length of the ring is nothing but a circumference, and we all know L equal to 2 pi r they put pi d, whatever may be. I can find out my length of the ring. So H is equal to, we all know, Ni by L. Okay, so the only unknown term is nothing but nu r. So substitute all the values and find out nu r. Check it whether you are getting or not. 600. Ah, yeah, Shivam, you're getting. Yeah. Kindly check it, ma. Kindly check it. Are you getting the answers? Yeah. Neha getting, Arul Mogit getting, Indra Sena, Rashmita, all are getting. Okay, ma. So I think if you know the formulas, these problems are very simple problem. And yeah, Arun Kumar also getting, as I said. So Adreya, Sai Kumar, yeah. I think shall I move on to the next problem? Have you taken now? You just take down. Yeah, Shrija also put. So people kindly see whether you are getting. Shall we move on to the next problem? Okay. I think it's a very simple problem. This type of problem they will ask in 6 marks. Are you clear on that? Okay. So I will move on to the next problem. Yes, you just take down a mild steel ring of mean circumference 50 centimeter. Okay, the circumference of the ring is 50 centimeter. Cross sectional area 5 centimeter square. Okay, I told you already the even though the length they given in centimeter, Our SI unit should be in meter. So convert all the terms in meter. Okay. And number of turns, 250 turns. Calculate the reluctance. Okay. And current required to produce a flux of 700 microweber. This symbol micro. Okay, we all know micro na 10 power minus 6. Take newer of a relative permeability of mild steel is 380. I told you the relative permeability only decides the flux passes through it. So relative permeability is high na, the flux, the ability of the medium to pass the more flux. Okay. Now we have to find out the value of S first. Okay. So I think first you find out S. We all know the formula, two formulas for S. What are the formula? I think I will go to that. We have a two formula, mmf by flux, L by A, nu naught into nu r. But we all know mmf na, the current we are already unknown, so we will take the second formula. Okay. L by nu A, that is nu naught nu R into A. I think all the datas are known. Length, the circumference is nothing but length of the ring. It's a ring. So circumference na 2 pi R, that is a length. So length they are given 50 meter, and nu naught 4 pi into 10 power minus 7, nu R 380, area 5 centimeter square, convert into meter square. So 5 into 10 power minus 4 meter square. So you can find out the reluctance. I think you people are getting the reluctance value, ma. Yeah, flux is 700 microweber. Microweber na you have to put 5 equal to 700 into 10 power minus 6. Actually, here the current calculation is not given. So first you find out whether you are getting the reluctance value, and the unit is ampere turns per Weber. So kindly put it, use the calculator, ma. You all remember the calculators are mandatory. So don't do any rough calculations. So yeah. Bhavana is getting, Rashmita is getting, Mogit is also getting. Okay, ma. Very good, very good. Okay, now the calculation is, we have to know the current flowing through the coil. Okay, so first we will find out uh, mmf, and from the mmf we will find out the current. Okay, and we all know what is the formula relating reluctance, flux, and mmf, ma. What is the formula? Ohm's law of magnetic circuits. mmf, flux, reluctance. Oh, sorry, I think the screen have stopped share. Yeah, I'm getting seven answers. Yeah. Yes, equal to mmf by flux, or mmf equal to flux into reluctance. Very good, very good, ma. So you find out mmf, find out the mmf value first. mmf equal to mmf equal to flux into reluctance. So what is the value of mmf you are getting? Yeah, all have put the values. I need answer. Shivam Pandey, Bharat, Sai Kumar, Jelson, Aranjana, all have put the answers. All have put the formulas. I need answer, ma. Bharat also put, yeah, tell me the answer. 1465.9. Is it correct, ma? 1465.9 ampere turns. Don't forget to mention the unit. You all remember the unit is very, very mandatory for all the formulas. So put the unit. Okay. Are you, please kindly check, ma, all of you getting this answer? Yeah, Rashmita is also getting. Yeah, very good. Shrija is also getting. Manasa getting. Yeah, very good. Very good. Ma Shivam Pandey is also getting. Okay. Thank you. Bharat, check your point missing is there. Adreya is also getting. Okay. And now tell me the formula for MMF. Now tell me the formula for MMF. Formula for MMF. Yeah, Neha, correct. N into I. Yeah, MMF is nothing but N into I. So MMF is nothing but N into I. And we all know number of turns and we all know MMF. Now you find out the current. MMF is 1465.9, or else we can take it. I think it's a problem. Can you able to view the screen, ma? Oh, 250 and put the current, find out the current what you're getting. I think this PPT have a thing, it will recognize my voice and typing. Okay. Current 5.86. Yeah, Rashmita, Mogit, Ganesh, Shrija, Dinesh, all are getting. Yeah, very good, very good, ma, very good. So the answer is 5.86. I think I will short 5.86. Yes. Okay, actually, I will share the screen because I am able to. Yeah. Students, shall we move on to the next problem? My current is 5.86. Are you all getting, ma? Are you getting? Shall we move on to the next problem? Yes. Yeah, all are getting. Thank you, students. So you just see this is the question where it's a university problem, ma. It is a university problem they asked in 6 marks. Last year university problem. Find the reluctance of circular path giving relative permeability 800, length 75 centimeter, and diameter 2.5 centimeter. Length they have given, permeability is given, diameter is given, and from that I have to find out area pi r square. Okay, and you substitute all and you check it. Very simple. I told you now the particular slide. If you remember all the formulas, then getting the answer is not tough for you. You check it. So I think you substitute all the values, ma, and you check it whether you are getting the reluctance. So I think I put the unit wrongly. Ampere turns per Weber. Are you getting the answers, ma? Arulmu Bhavana, you are getting some other answer. Rashmita also. Check it. Yeah, area you're calculating separately. Okay, okay. You check it, and this will be the answer. Today I will share this PPT, ma. Whatever I thought till today, and to next week we will give you the assignment to write. Okay. So I think we will give one more week for you to complete. So students, now you can able to go through that, ma. Yeah, you check it. I think, shall we move on to the next problem? So I think the problems are not much complicated. Okay. The problems are not much complicated. Just you have to know remember the formulas. Remembering the formulas, substitute the values, then you will get the answer easily. Okay, I think some of them were posted. Shivam, Bhavana have posted the answer. Arun Kumar has got, yeah, Sai Kumar also. Okay, ma. Okay, thank you, students. I think I will move on to the next slide. I think the problem almost we have seen all type of problem. Yeah. Next, the problems are over, ma. So if they ask a problem in this unit from this part, actually in another part you have some other problems. But if the problems are from magnetic circuit, they ask you to calculate a very simple thing. You have to remember the formula, substitute the values, and you will get the answers. Okay, ma. The next one, these are all, sometime they may ask you to write short notes on. I think yes, I have shared your previous year university question paper to you. So there they asked, write a short notes on retentivity, leakage flux and all. So this is sometime they may ask you to define or write a short notes in a 6 mark question. You are supposed to write. Okay, now we will see about what is leakage flux. Okay, actually this is 5L. Okay. Yeah, students, we will move on to the next topic. What is leakage flux? You have to understand that. Okay, I think if I am teaching the classes, some of them were putting the answers, some of them were listening, and some of them audio is not connected. Okay, so whatever I am teaching, it reaches to you. Similarly, the flux will be produced in the iron core where it will do the useful work. What is useful work? We all know the interaction of both electric and magnetic circuit only. The energy conversion is taking place. So you all have to know the energy conversion has to take place now. Both the field is mandatory. So the designing part of the machine does not stick on over the electrical part. It has to be considered over the magnetic pulse also. So what happened, we have seen the generator part, motor and all, there will be and magnets will be there, or electromagnet or permanent magnet, whatever may be. So what happened, the magnetic field will be produced, so it will pass us to the conductor. We all know what is the motor principle. Whenever a current carrying conductor is placed in a magnetic field, it experiences a force. Okay, so similarly, what is the generator principle? A conductor is rotated in a uniform magnetic field, and EMF will be induced. So what happened now, this magnetic field will cross to the conductor, so it has to sweep over the air gap. So that particular flux is a useful flux which is used to mainly do the energy conversion. Are you clear or not? So that is useful flux. That's why I gave you the example. Whatever thought I thought, I'm getting only some of the name is very rememberable to me, because the people are keep on answering me. Some of the names is very, not known to me. Actually, by seeing the attendance only, I can able to know who are all the students and all. So those who are take parting in the class, and they are giving the answers and all, they can understand the subject very well. So similarly, the flux which is used to do the useful, ma'am, is there any issue if camera is not connected? No problem, Shivam Pandey. Actually, the camera we were not going to take part. We just going to see how long you were be in the class. That is the main thing. Camera, audio, not mandatory. Okay. So the flux passes through the air gap is known as useful flux. You can understand why it is useful flux, because it will sweeps over the conductor, which where the energy, whether it is a motor, force will be exerted on the conductor. If it is a generator, it will produce the EMF induced in the coil. So that flux will be the useful flux. So you just see it's a iron ring or any ring where the coil is wound around that, and I am passing the current flow through the coil. So automatically what happened? The flux will be developed in the coil. So this particular flux which passes through the entire magnetic field. We all know flux means what? Total number of magnetic lines. Okay, we all know the electromagnet or a permanent magnet where the magnetic lines will be exerted. So the total number of magnetic lines will be called as a flux. So the flux which does the useful work, that is called as a useful flux. Some of the flux will leakage. You just see around the coil, the flux will be leakage. That is called as a leakage flux. What is leakage flux now? The flux which does not links through the particular coil, it does not takes place on the energy conversion. That particular flux is called as a leakage flux. So what they are saying now, the total flux produced in the ring is equal to, iron ring is equal to useful flux plus leakage flux. That is pi L is nothing but a leakage flux. Pi G is nothing but a useful flux. Why they are saying useful flux in air gap? That's why I have explained to you. Because a flux which is produced in the magnetic core or in an electromagnet, definitely it will passes through the air gap. Then only it will links the conductor. Then only we will see that energy conversion is taking. So leakage flux is nothing but a total flux minus a useful flux. That is called as a leakage flux. When yeah, Sai Kumar, very good, very good, very good. When primary and secondary windings are more close to each other, leakage flux is the next figure. I am going to see how the leakage flux is okay. And another important to mark, leakage factor. You people kindly note down. I told you this will be the important to mark. What is the formula for leakage factor? Leakage factor means total flux produced by useful flux. Are you clear or not? The total flux reduced by useful flux. Here they gave given that my leakage is neglected now. The lambda is equal to 1. Are you clear or not? When the lambda is equal to 1, total flux and useful flux are the same. So automatically the leakage flux get reduced. So that is called as both the flux will be same. So at that time lambda will be 1, or else my lambda will be always greater than 1. I will move on to the next slide where it denotes that you just see my lambda will be always greater than 1. Why ma? My total flux is always greater than useful flux. So that means my lambda will be always greater than 1. The lambda will be always, the lambda value should be always in the range of 1.12 to 1.125. Okay. So I have given the figure that Sai Kumar said that there will be a primary winding where I will give my AC supply, and there will be a secondary winding where I will connect my load. And you just see, once I give the AC supply, here I'm giving AC supply. That means what happened now? If I give a AC supply, the flux produced in the machine will be a time varying flux. Are you clear or not? Time varying flux means what? You just see this. I will draw. What is time varying flux? Huh? This is my time varying flux. If I give AC supply, I will get a time varying flux. So here what happened, this time varying flux will links the secondary coil and EMF will be induced in the secondary. But you see some of the flux which gone through, which is nearby the coil, which does not possess any useful work, that is called as a leakage flux. Have you understand or not? Okay, I'm getting some. Yeah, that is called as Shivam Pandey is correct. Ideal value. Lambda equal to 1 means it we used to say it's ideal. That means what? Whatever I'm telling in the class, you people all are listening in the class, then automatically the result will be 100%. But sometime only it is possible. Okay. So that condition we used to say it's a ideal condition. Okay. So I think you have take down leakage flux. So you people they ask you about a leakage flux. You are supposed to explain what is leakage flux, and you draw the diagram, write the theory over it, and write down about leakage factor and the value of the leakage factor, and the flux which passes through the air gap, that is called as a leakage flux. Ma'am, can you explain once again? Yeah, I have told you. See, this is a iron ring. We wound the coil around the ring. The current will passes through it. So automatically flux will be produced. You all understand? If I am giving a DC current, my flux is also a constant. Okay, that is my flux is also a constant flux. It doesn't vary with respect to time. Are you clear or not? Okay. Now I am saying uh, in any machine there will be a magnetic and a conductor. Okay, so I will go to the image here, where you will see. Okay, I think yeah, you just see here it is a magnet and here it is a coil. So what happened now, my flux will passes through to the conductor in the air gap. Okay, that flux is called as a useful flux. What is useful flux now? The flux which is mainly used for the energy conversion, that flux is useful flux. And some of the flux does not passes the air gap and it will leaks through the air surrounding the ring, that is called as a leakage flux. So total flux is equal to leakage flux plus useful flux, that we are saying. So what is the formula for leakage factor? They are saying lambda means total flux by useful flux. Are you clear? Okay. Siddharth, I am saying after completing the class, I will send you the PPT. Don't worry on that. Okay. Whatever I complete till today, I will send the PPT. Okay. So you understand total flux by useful flux. So at what condition total flux, what condition lambda will equal to 1 now? There will be no leakage flux. Total flux will be equal to useful flux. But it is said to be ideal condition. So the lambda will be greater than 1. That is obviously the value will be in the range of 1.12 to 1.25. Okay. Okay. Then I will move on to the next topic. Fringing, this is also one of the important tumor. It is actually the continuous of the leakage flux only. Okay, so we were saying the flux which passes through the air gap is called as a useful flux. So what happened, my flux which passes through the air gap, it will be bulge outward at the edges of the ring. Okay, sometimes the flux will be flows like this, so that effect is called as a fringing effect. Okay, so what is the disadvantage? Shankar, I'm keep on taking the class. You are asking, ma'am, when will the college reopens? Okay, so students, I think offline class will be. We also can see the student face and we can able to teach. And one more thing, you understand. Once we got the approval from the government only, all the thing will take place. No one can decide. It's all in the government hand only. Now only the count is getting reduced. So when the count will become very low only we can able to decide. Can you understand? So don't worry on that. We will also want to meet the students, and you are in the first year, you are missing the college life, and those who are in the final year, they can't enjoy, they can't able to come to the college. So all the problem we were facing. So now you listen the class. Are you clear? Okay. uh, we are diverting from the topic. Fringing, what is fringing and all now? When the flux passes through the air gap, it will bulge out across the edges of the air gap. This effect is called fringing. So what happened due to the fringing? So you just see, I have drawn the fringing fields and all. So what happened now? The area of the air gap get increases. We all know the flux density formula, B equal to phi by A. So area of the air gap get increases now. What happened? My flux density get reduced. So that is the disadvantage on the fringing effect. Okay, can you understand or not? So if the air gap is very small, sometimes they will keep in micromillimeter or some millimeter and all. The area will be very low now. We can neglect. Sometimes the area will be in the length will be, or the area will be in the centimeter and all. Definitely we have to include that fringing effect. Then automatically the flux density get reduced. So you people have to understand. Yeah, Indrasena is correct. It is decreased. So this is how the fringing effect which affects the flux density of the air gap. Are you clear? Okay, that's all. This is also one of the 2 mark. So today we have seen leakage flux is also 2 marks. Sometimes they may ask you to write short note now. You have to explain till this. Okay, another 2 marks are fringing we have seen, and leakage factor we have seen. Okay, then retentivity. Actually, you think you have hear this word retentivity. Um, I think in hysteresis curve you have heard the word retentivity. That means the ability of the magnetic material, even the magnetism is removed. some magnetizing force will be exist on that particular thing. That is called as a retentivity, that we used to say residual magnetism. So the magnetism remain in the magnetic material even when the magnetic field is reduced to zero. Even the H is reduced to zero. I think while we are seeing in this, while we are drawing the hysteresis curve, this is called as a retentivity. I think I will I will show you the retentivity in the next graph. Even we will have a magnetic field strength and a magnetic field intensity, where my magnetic field strength is zero. There will be some magnetism. Even the removal of the magnetic material, even the magnetic field is reduced to zero. That is called as a residual magnetism, and that is retentivity. Where it is mainly used in all, we see, you all know, while they are designing any relay solenoid, they will have a lower retentivity. Depending upon the material also, the retentivity will be there. So you all understand that while we are designing any electrical machine, the electrical part is how important. Similarly, the magnetic part is also very, very important. How they are choosing the magnetic material, what is the flux around that material, and what is the magnetic flux density, magnetic field strength, and what is the residual magnetism will be there. When you see, when we have a DC generator that is mainly used in electrical locomotives, still today we have a, even though we have replaced all this machine, we have a DC generator in electrical locomotives, where the residual magnetism will be there only. It will develop the voltage there. So residual magnetism, it is very, very important. Okay. So I think I will show you the figure. There you can see the retentivity in the hysteresis curve. Actually, we were not focusing on the hysteresis curve. You just see, even the magnetic field strength is zero. There will be some residual magnetism, that is called as a retentivity. And you just see the below, I have put it two images for you: soft and hard magnetic material. So you have to understand how they were choosing the soft magnetic material, hard magnetic material, and all. You have seen my soft ion magnetic material mainly used in transformers, motors, generators, or any audio coils and pulse transformers, amplifiers, and all they were using. Okay, and similarly loudspeakers, electrical meters, and some permanent magnet, they will use the hard magnetic material. So how they will choose this magnetic material? Now mainly the hysteresis curves playing a vital role, where it have a low retentivity, low coercivity. So here you just see, it is the ability of the ferromagnetic material, where my BNH is zero, still it have an withstand an external magnetic without becoming a demagnetized. That is called as a coercivity. So you just see soft magnetic, hard magnetic. So the soft magnetic means it have low retentivity and low coercivity. And while you're seeing the loop, it have a small hysteresis loop, and it is a high saturation magnetic material. So this type of magnetic material only they will mainly choose in the electrical machines. So hard magnetic material that have high retentivity, high coercivity, even they have a large hysteresis loss, that is, and high saturation magnetization characteristics. They suitable for, this is for temporary magnetism, and this is for permanent magnetism. Are you clear or not? So temporary magnetism, whenever I supply any coil, it will be get magnetized, and depending upon that it will work. Actually, most of that, yeah, Rashmita, right? This is the magnetism. So retentivity, they ask about that. So you have to explain. Actually, we all know the hysteresis curve. When I increase the B value, it will goes to, still when I increase the H value, B value is also correspondingly increases, and it depends on nu naught and nu r. And this particular curve have explained using B equal to nu H. And we all know nu r will be the relative permeability of the material. So when the relative permeability of the material will varies, my hysteresis loop is also varies, and it also mainly depends upon the retentivity and coercivity of the material. So it never follows the same path. So that's why we are getting the hysteresis curve. So the hysteresis curves, mainly the hysteresis loss will be also there. So depending upon the hysteresis curve shape, the loss will also be decided. Are you clear? So today I have we have seen some problems, and then if they ask, write short notes on leakage or retentivity, you may have to explain this. Okay. Then one of the important question, ma. Ma'am, go slow. Hemnath. What? Okay, okay, Hemnath. Actually, the retentivity, coercivity, I think you people have understand well, and I think you can understand this both soft and hard magnetic material, which have a mainly they will choose the property of retentivity, and then they will choose it for the particular applications. Is clear, ma? Okay. Now the next important question. This is one important part B question, 16 mark question. Analogy of a magnetic and electric circuit, or the question may be write the similarity and dissimilarity. Analogy means it's the same thing. Similarity and dissimilarity of electric and magnetic circuits. So you people have to explain it. Actually, you have to put it in a tabular column and you have to explain it. And yesterday itself, we have already correlated. So, whatever we studied yesterday, the same topic only, I'm going to choose. Oh, okay. So, nearly you just see I am having 15 points. So, 16th point, I will draw the curve and I will draw the diagram and I will finish it up. So, you people have to understand. Okay, we will see one by one point. Okay, magnetic circuit. Okay, we all know the closed path for the magnetic flux is called as a magnetic circuit. Okay, and what is electric circuit? The closed path for the electric current is called electric circuit. So we all know the magnetic field. The magnetic field will be created by the temporary magnet, permanent magnet, or we all know electromagnets and all. So the closed path for the magnetic flux is called magnetic circuit. We are saying a total number of magnetic lines will be called as a flux. So here the closed path for electric current is called electric circuit. Are you clear? Okay. Here flux. I am saying magnetic flux in Weber. The unit is Weber. And here electric current. Current means I. Capital I only we will denote. That should be in ampere. Okay, I think if possible you take it, or else I will share the PPT, but you have to understand what is the analogy or similarity or dissimilarity. Okay, magnetomotive force, NI, magnetomotive force. That's why I told you mmf. Mmf means what? N into I. Mmf is nothing but N into I in ampere turns. Electromotive force, that is nothing but my voltage or my potential difference, where it is used to drive the electric current in a electric circuit. That is electromotive force. Magnetomotive force is mainly used to produce the flux in the circuit. Electromotive forces used to drive the current in the circuit. Okay, so the unit for a magnetomotive is ampere turns, and the unit for voltage is volt. Okay, and electric flux, yeah, okay, electromotive volts. Okay, and magnetic flux, actually phi, the symbol it is that doesn't recognize. Phi equal to mmf by reluctance, and here current is equal to emf. EMF means what? Electromotive force, which is the driving force, where it is used to circulate the current in the circuit, and it is used to circulate the flux in the circuit, magnetomotive force. Okay, so V equal to IR, we are saying I equal to V by R. Here flux equal to mmf by reluctance. So you have to understand what is resistance and what is reluctance. We all know reluctance will oppose the flux in the circuit, and resistance will oppose the current in the circuit. Okay, so the formula for reluctance, S equal to L by nu naught into nu R into A, or we will say L by nu A. Okay, and we all know nu is the permeability. And here the formula, actually you have to understand the reluctance is also depends upon the material. Are you clear? Magnetic material, length of the coil, permeability of the coil, that is relative permeability of the coil, area of the coil. It also depends upon the material of the core. Similarly, resistance, Resistance also depends upon the material, like specific resistivity, length of the coil, and the area of the coil. So you have to understand the resistance also depends upon the material. R equal to rho L by A. So one of the important 2 mark in first unit. The resistance depends upon the materials like rho, resistivity, length, and area. Okay, and we all know the uh, inverse of reluctance is permeance. The reciprocal of reluctance is permeance, and the reciprocal of resistance is conductance. And we all know the unit of permeance is what? Weber per ampere turns. And the unit of conductance is what? Mho. We used to say mho. Okay. And permeance means what? Reciprocal of reluctance. Conductance means what? Reciprocal of resistance. Okay. And here we used to say permeability, nu. Okay. And here we used to say conductivity, sigma. We have studied. What is the relation between conductivity and resistivity, ma? Can anyone tell? Conductivity and inversely proportional. Atreya, good. Nega, yeah, inversely, correct, right. Yeah, conductivity is nothing but inversely proportional to resistivity. Thank you, ma. Thank you. Okay, so here we used to say permeability. So permeability will decide the ability of the material to pass the flux through it. So sigma is the conductivity where it mainly used to pass the current flowing through it. Okay, then flux density. How we were calculating the flux density now? Flux per specified area. Are you clear? Flux per specified area. So B equal to 5 by A. Weber per meter square. Flux density. Flux per area. And current density. I think here we didn't use the current density, but you have already studied current per unit area is nothing but current density. Okay. So current density means current per area. So the obviously here Weber per meter square, and I told you Tesla. Tesla. Okay, and here ampere per meter square. So the unit is ampere per meter square. So Tesla, which he's having the so many patent in his name, highest patent. Okay, and magnetic intensity. I think this we studied magnetic field strength, magnetic intensity. What is the main role of magnetic? It only strengthen or weaken the magnetic field. What is the formula for H? MMF by length. I think Ni by L. MMF means what? N into I. So MMF by length. So the unit is ampere turns per meter. Electric field intensity. I think you have studied or not. I don't know. But mainly where it will be is now we have a concept of field theory subject where the charge will be there now. How long the electric field will be around the charge, that we used to say that E equal to V by D, voltage by distance. Are you clear or not? So electric field is intensity means voltage by distance, here mmf by length. So the unit is here ampere turns per meter, here volt per meter. Okay, so the electric field intensity we can acquire how long the charge will exist, the electric field around the charge and all we used to calculate. And you have find out the force between the charge and all. I think you have studied if there will be attractive force or repulsive force we will measure. So similarly here also the magnetic field intensity, which will denotes the strength or weaken of the magnetic field, and electric field intensity, it is mainly focus the voltage by distance. Okay, magnetic flux does not actually flow in a magnetic circuit. Actually we were saying close to path, it is a one imaginary line. Actually we can able to um, uh, we can able to know the force will be exerted where we can place the uh, where the magnetic field is there. If I placed any charged conductor in that magnetic field, automatically we can able to feel that, but we cannot say it is actually flowing. Okay, we can say the flux is nothing but a total number of magnetic lines of force, but electric current actually flows. Electric current actually flows, and even though both are invisible, but one thing we can say, in the closed circuit only, the electric current will flow. Okay. The next, I think people have gone through the 11 points, how we compare the magnetic and electric. I told you it's one of the important part B, very important part B. If they ask this question, if any other choice is given, don't give importance to that choice. Kindly write down the question. Are you clear? Because very, very simple question and you people can able to answer it. Then the reluctance of the magnetic circuit is not constant. It depends on the flux density in the material. Even though we were saying the reluctance value, okay, we all know that is not constant. When flux density of the material get changes, we all know B equal to nu h, then reluctance is also will changes. The resistance of the electric circuit is practically constant, even though it varies slightly with the temperature. Actually, when you see the resistivity length and area, when we fix the resistance, when the resistance will change now, R equal to rho L by A, we are saying now, when the resistance will increase now, we used to say temperature coefficient. Positive temperature coefficient, negative temperature coefficient. I think you have feel in the lab. When sometime more current is flowing through the coil, what happen now? The resistance color will turn into black color. That means what happen now? The resistance is going to burn. And one more thing, the resistance due to temperature, the resistance value get is increasing or decreasing, whether it is a positive temperature or negative temperature coefficient. Okay. Arun Kumar, still now we didn't write any test. Once I gave the assignment we will correct or some other stuff, because so many faculty members were taking the first year computers in, that and all decided by the subject coordinator. We won't decide anything. But you understand that we were teaching only common syllabus and we are taking the same type of thing only. So whoever correct, and when you go with university, any person can correct. So don't think that we always correct you or evaluate your paper. Okay, and taking the class, you people have some multiple doubts. Huh? Okay, and now in magnetic circuit is required to create the flux and not to maintain it. Okay, so what happened now in magnetic circuit? One we were saying now, 10 power 8 lines of force is equal to 1 Weber. It is used to create the flux and not to maintain. But actually in an electric circuit, the energy is always required. Okay, without electrical energy, the current has to flow, means the energy is always required, but here it is not like that. Okay, and one more important point, there is no perfect magnetic insulator. That is the main thing. uh, but when you see that so many electrical insulators are available, glass, air, rubber and all, we will take it as a electrical insulator. Okay, and Ohm's law in a magnetic circuit, mmf equal to flux into reluctance. Okay, and here emf equal to current into resistance. And one more time you can draw the diagram here. Okay, actually while I am drawing, I think I have taken the diagram. I think I will show you. And here it is nothing but here. Okay, here resistance na, here resistance na, here reluctance, here current na, here obviously it is a flux, and here mmf na, here emf. Okay, so kindly write 16 points, then obviously you'll get 16 marks. First semester exams are at home or college. I think your classes are not till over. So if the when the classes are over and when the government asks to conduct the exam, when the government asks to reopen the college, definitely you will write it in college. Okay, that is not. We never able to predict the future. Even though we have invented so many things, we never expected this kind of online classes and all. So we will write, but you have to prepare how you are preparing for exam. You have to prepare like that. Okay, I think this diagram I have shown in the previous class. Okay, yeah, this diagram finally you draw it. Okay, so then I think practical, we were not having any practical for you. I think you got the information from your year coordinator. They will conduct on Friday and Saturday as a virtual lab, so be focused on that. Okay, so people, have you understand analogy of magnetic and electric circuits? Are you clear, ma'am? Okay. Yes, analogy. Which questions we have to prepare for exam? I told you first unit you have only mesh and nodal analysis will be there, and in second unit you have the questions we have to be from theoretical part or problematic part. Okay, so I think shall we move on? Only in first semester, yes, Shubham Kumar, it will be only in the first semester. Next semester you don't have any electrical subjects, but you have digital papers will be there. Okay, electrical na, it have electronics also. The 3 unit only electrical. Will you send questions? Actually you have only 1 year questions because it's a 2019 regulations. I think I have sent to you any PDF. Will you send on questions, ma'am? Actually, question paper is a previous year question I'm having, but the problem is what now? Their syllabus and your syllabus is somewhat changed, so I can't share it because you got confused by seeing the question paper. So from that, whichever question is very important that I gave and I gave you even in the first unit, at the last of your first unit, I gave some problem for practice. That are all university questions, and in the second unit PPTs also I gave you some important part A and part B question. That is also that I'm having only one question paper. That is I already shared to you. So today also I will share the same question paper to you. It's clear. Okay. Today after completing the third, is graphing calculator allowed in exams? Graphing calculator, no? Calculator will be allowed, ma. You can use the calculator. Okay. Actually, calculator only allowed. You can't take it in any mobile or your smart watches are not allowed. Only the calculator will be allowed inside the examination. Yeah, 911, FX91. Okay. Mm, I think the time, Bhuneshwari ma'am.
Yes, ma'am.
Ma'am, what is the exact time? You have the time? We can.
Five more minutes.
5 more minutes is there. Actually, why the strength is 208 now?
Strength has got very much reduced. Initially, it was around 240,
Uh,
then 220.
you
Now it
all
has
went.
come so less.
You all went take your lunch, amma.